Go ahead.
Thank you very much, Patrick. So today we're going to deal with sound, and we'll learn how to make beautiful noises like that and deal with harmonics. So today, I want you to write this down. This is your learning objective today. This is what we're going to accomplish. You're going to experimentally calculate the speed in which sound travels in propane, which is not normally the medium that we are in.
Are you sure?
Yes, as it turns out. So go ahead and write this down. Does anyone know how fast sound moves in regular air?
43 meters per second.
Very good. How fast does it move in space?
You trickster.
Trick question.
Not a trick question. It's the same answer as any. Just different than most. Let's do a quick review of some of the things we've been looking at. So remember, waves interact constructively and deconstructively. They interact with each other. So if I start one pulse, then another pulse, when they meet, they're going to interact with each other. Here they are both going, they both have the same direction of amplitude, so they're going to interact constructively, meaning they're going to add together. Whoa. When they're moving in opposite directions, they will interact deconstructively. What? You see, they cancel each other out.
Very good.
And then if I do an oscillation, you'll see that when the waves come back and reflect backwards, they're going to keep interacting with these waves coming this way. And then what is produced is a what?
Standing wave.
Very good, a standing wave. So remember we did this with this fun little giant slinky. Beautiful. Today what we're going to be doing with is a little bit different. So we're dealing with sound waves. So sound waves are longitudinal rather than transverse. So you're still going to get the same standing waves, same type of standing waves, but the way that they propagate is a little different. So this is a little visual of this. So this is regular transverse. Whoops. Start. That'd be a regular transverse. But if I'm doing longitudinal, it's more like this. So you still have points. So, around here where's your node where it's not moving, that will still be a node. You see it's still not moving back and forth. And still your points that were moving up and down the most, those are still your points that are moving side to side the most. So it's very similar to transverse, but just a little different. Transverse. Whoop. Today what we're dealing with is sound waves, longitudinal. And specifically what we're dealing with are sound waves in a tube, a closed tube, or stopped end. So, I believe we've all looked at these. So this is all review. Your first harmonic or first fundamental frequency in a closed tube. Remember we can only have a first, a third, and a fifth, seventh, odd numbers. So these are the way that the waves will look, the sound waves. And you can see inversely, the pressure is a little bit different. The pressure is opposite, which will show you a good visual of this here soon. So that's how a transverse wave would look in these tubes. Here's how it actually looks, you know, when the air molecules are propagating through these longitudinal waves. So you can see you have your sound wave, and where you have the antinodes, that's where the most movement is. But in the same sense, when you have these nodes, that's where your greatest pressure is. That's where all the air is pushing together. And when we're dealing with the Rubens tube, which I think you're all familiar with and you've been looking at and eyeing up for the last couple of days, that's where we're actually going to see the waves forming, the peaks forming from these pressures. But when you note, it's not going to affect our calculations too much, because for every, you know, if you have two nodes in a tube, you also have two antinodes. So what we're looking at is the same number of peaks and valleys. All right, well, I think we're about ready to get started with this. I'd like you to do one thing for me first, and that is together in groups, maybe pairs, pair-group groups. I'd like you to draw the first 6 harmonics that you can have in a closed pipe. So draw those visuals for me. And those were so basically I want these drawings, but for the first 6 harmonics that you can have in a closed tube. Thank you. All right, so I'm going to come around and check to make sure you guys are getting these. Excellent job so far. Yeah. Yep, you got it. First one. So you have an opening, and then you're going to need another. So it's going to need to be a node here at this base, and antinode here. Yeah. So very good. You got it. So draw one, and draw this one. So you know that's one. And then look here, so you can stop there. So that's your first one. Does that make sense? Okay, so that's your third. And then the next one, you're going to have one more of these. So that would be your fifth. So this would be your third. Because it needs to start with the closed and then with the open. So here's the first one. That's the first one. And the next time you can do that is here. Next time after that, you can do that is here. And then one more would be there.
So tomorrow. You have to already
Awesome. Yeah, and these are difficult to do once you get up to 6. You get a lot of circles in there. But we're going to have a lot of peaks in our actual tube. So I want you to start visualizing them now. So the first time you can do those two. Open. And close. So the first one you can do that. Second one you can do it. So if you were to keep doing this, here's your first one. Here's your second. Yeah. Here's your third. Fourth. They are, because if you multiply this frequency, this fundamental frequency by 3, you get this. Technically, yeah, but it's not right now. Yeah, exactly. Oh, excellent. Yes, yeah. Very nice. Yes. That's the first one. That's the first one. Yeah. Second one, that's the first one. Here's the second, here's the third. So you can see the frequencies. You know, this frequency, this is 3 times. It's 1, 2. It's just the next time you do it.
Pretty sure it's because of
Also, this is your closing. Yeah, very good. These are awesome. Very nice. Oh, excellent. Very nice. Would someone like to come and draw their beautiful? These are nice.
I actually did these. I did these ones and you did those.
Would you like to draw these up there?
I'll do it.
Which ones?
What? Hey, you guys. Do you want to, or if you don't, he wants to.
Patrick.
Patrick wants to. Patrick, come on up.
How many do I have to draw?
Let's draw the first 6. Let me.
Can I just draw this big one?
I'm sorry.
That's my best one.
Did you enjoy yours? Yeah.
If they're right, yeah, I'll draw.
So you need to look at this one. So here's your next one that you draw. That'll be 3.
Oh, okay.
Okay, so that's 5. That's 5.
Oh, okay, I see. Okay, got it.
Run while you're getting and then you stretch it out. So that's the length of your leg. So here's the first time now it's closed. Open. So I mean you could always go for the next one. Let me because you're not closed. Because I don't. You want to
That's the first one you see the post.
I'll draw the first one.
Can't get much easier.
Well, yeah.
There's something I Oh, there's 2 more. We need to should have been.
They're not. This is actually set.
Alright, so you guys.
Just they couldn't have them in the booth because of Jack. I don't think he pressed the button.
Yeah, don't press it.
Yeah, we're talking about in the comments. Yeah.
He's gonna draw these for us. So it looks like most of you guys are getting these very well. A few of you still have troubles. But I think we're gonna work that out right now. If you guys can follow this, we can keep going. Okay, here's the first one where I think but he hasn't checked out soon. Here's the second one. So yeah, just don't freak out. It's all right. You're good. All right, let's see how he's doing. I wasn't paying attention. Is he doing all right?
Yeah.
Except that fifth one got a little messed up.
That looks pretty nice to me.
No, the fifth one's right.
They get tough to do after a while.
He doesn't.
Ian's pretty good with that marker, that pen.
He is. He should be a teacher someday. Excellent job. Excellent job. Warm round of applause. All right. So these look very good to me. Let's label these though as harmonics. So let's try someone else. Neil, which harmonic is this?
Number 1.
You got it.
Yeah.
All right. Kayla, which one is this?
3.
3. Very good.
No, it's 3.
Chad, how about this one?
5.
You got it. Okay, let's really throw you off. Which one's this? Christian?
7.
Why do you think it's 7?
It was just a guess too.
Oh, well, you shouldn't have guesses, so we need something to support your guesses. So, this one is 1. 1, 3, 5. And then you keep going on the progression. You can see that the wavelength here, so this is a third of this. So really, this frequency keeps increasing by, this is 3 times the frequency of this. This is 5 times the frequency of this, assuming they're the same length, 2. So, maybe this is an easier question, Christian. Which one is this? Oh.
7. Oh.
You're right. Go ahead and say it. 7. So, why do you feel that this is the 7th one? What's some criteria that you would choose?
Well, I'm kind of noticing a pattern with because the waves they form those ovals.
Yeah.
The third one,
So here's your antinodes and here's your nodes.
the fifth one has 3. The third one has 1.
Okay, so your first one has 3 of these open spots. And this one has 1, 2, you're saying.
Yeah.
So you keep seeing them progress, and then this one has 4 is what you're saying, so it's the next one up.
Yeah.
And you're seeing how these numbers increase. So you're just seeing the pattern here?
Yeah.
Okay. So you're right, this one is the 7th. I'll take that as a pretty valid answer. Also, you can see that this frequency is 7 times greater than this fundamental one. So each of these blocks, I'll go ahead and draw them on here. So this is 1 of these. 2, 3, 4, 5, 6, 7. So this is 7 times the frequency of this one. You see that? And the wavelength is 1/7. Oh. I gave you the hardest one. All right, so now this one. Vaughn.
9.
9. Very good. And who wants to help me out with this one? Peyton?
11.
11. Very good. Christian, does that help? Excellent. All right, any questions on these? You guys ready to watch me play with fire?
Yes.
Fair enough.
Let's light things
Made you
on
wait way too long.
fire.
Do you want us to get our instruments?
Not right now.